Hello everyone. In this video I'm going to speak about salt hydrolysis. Let's get started. We already know that the reaction between acid and base should produce salt and water. But we'd like to know what's the effect of the salt hydrolysis on the water's pH. First of all, we have to know that we have three scenarios: acidic effect, basic effect, no effect. What's the acidic effect, or how the salt could make the solution acidic? If the salt is formed from strong acid and weak base, so it has an acidic effect on the solution. Let's check an example. We have here NH4Cl. NH4Cl is produced from the reaction between NH3, which is a weak base, and HCl, which is a strong acid, and it's producing NH4Cl. We have to know that NH4 positive is coming from weak base, so it is a strong conjugate acid. While the Cl, the other ion, Cl negative, is coming from strong acid, so it's a weak conjugate base. Why this is an important point? This is what we will know now. Now we'd like to know how well the salt hydrolysis take place in water. We have here the salt, NH4Cl. It will dissociate in water to produce NH4 plus Cl negative. We have NH4 plus, which is a strong conjugate base. Okay, if we have a strong acid, it means that it will affect the solution, while Cl negative is weak conjugate base. How this strong conjugate acid would affect the water? We already know that the strong acid is dissociating in water to produce hydrogen ion, and this is what will happen. NH4 plus will dissociate in water to produce H plus that will make NH3 and of course H3O plus, which will make the solution acidic. So this is the first scenario. The second scenario, the basic effect. If the salt that we have is coming from weak acid and strong base, so it will make the solution basic. How this will happen? Let's check an example. We have CH3COONA. What are the acid and the base that made this salt? They are CH3COOH, which is a weak acid, and NaOH, which is a strong base. Of course, weak acid will make strong conjugate base, which is CH3COO. This ion, this negative ion of the salt is a strong base, and NaOH will, of course, produce a weak conjugate acid. Again, how will the salt hydrolysis take place in water? We have here the salt. It will decompose to produce these two ions. We already know that this CH3COO negative is a strong conjugate base, while Na positive is a weak conjugate acid, which means that this strong will interact with water. How it will interact with water? It is depending on if it's acid or base. It is base, so it will interact with water by gaining H+. The acid in the first scenario interacted with water by producing H+, but the base will gain H+. So when it's gaining H+, it will produce or it will leave OH ions in the solution, which will make the solution basic. So it is mainly depending on the conjugate acid or base. If it is strong conjugate base, it will interact with water by gaining H, like here. If it is strong conjugate acid, it will interact with water by producing H+, leaving H3O positive, which will make it acidic. But in the second scenario, it interacted and gained H+ from water, leaving OH negative, and it made the solution basic. The third scenario, no effect if the salt is formed from strong acid and strong base. We have here an example, NaCl is coming from HCl, which is strong acid, NaOH, strong base. Of course, the ions that are making the salt are both weak conjugate acid and weak conjugate base, which means that when the salt will hydrolysis in water, it will produce Na plus Cl negative. Both of them are weak. They will never interact with water. So the ions produced will not affect the water's pH because they are weak, and this salt will not affect the solution. It will never make it acidic or basic. It will just keep it as it is.